Welcome, everyone. In this section 7.5 of chapter 7, we are going to do the strategy for integration. We have seen some integration techniques. 7.1 about integration by parts, 7.2 trick combinations, um, 7.3 is about trick substitution, then 7.4 is about partial fractions and how to integrate. So here we have, after learning four techniques and along with substitution technique that you learned in my Calc 1 class, now we have learned some techniques to integrate by recognizing the integrand. Now in this section, we are going to see some strategies and how we recognize the function, recognize the integrand, and then apply a proper integration technique. So, in your earlier classes, you have learned some of the basic integration formulas, like power rule, the first one, and then integral x to the n is x to the n plus 1 over n plus 1. You can refer your handout for these formulas. See, there are some formulas which are basic. There are some formulas which we actually were derived. This one we actually derived here, and some of them can be derived. And it's worthwhile memorizing them because we will be using them quite often in the upcoming sections and chapters. So let's see this first example, how we simplify an integrand and then we can integrate. So simplifying an integrand may be one option to integrate the given function. So if you are given integral square root of x times 1 plus root of x dx, first we will simplify, meaning we'll expand this. I expand, which means you distribute root of x times 1 root of x, then root of x times root of x, that is an x. So we rewrote the given expression like root of x plus x. Now it is easy to integrate by power rule of integration. So it is integral x to the 1 half plus x to the 1 dx. So when you integrate, it's going to be, I'm going to call the given integral as I. So it's x to the 1 half plus 1, which is 3 halves divided by 3 halves plus x square over 2. Being indefinite integral, you have to add the c. Then you clean this up. So write 3 over 2 in the denominator as 2 over 3. X to the 3 halves, or you can also write x to the 3 halves as x times root of x. Another way of writing same x to the 3 halves plus x squared over 2 plus an additive constant, an arbitrary constant. So simplifying the integrand is one of the strategies. Now let's try the example. Example number 2. Integrate tan theta over secant square theta. If it was switched, like if the numerator was in the denominator and the denominator was on the numerator, substitution technique would have worked. But here, as secant square occurs in the denominator, we have to try a different technique. So one of which is to write tan theta and secant square theta in terms of sine and cosine. So tan is sine over cosine. Then you're going to have secant square theta, which is 1 over cosine square theta. It's the reciprocal of cosine is secant. So secant theta is 1 over cosine theta. And we also used tan theta, which is sine theta over cosine theta. So we have I equal to sine theta, integral of sine theta over cosine theta, flip and multiply. So cosine square theta over 1 theta. So 1 cosine theta would get cancelled out. So you get I equal to integral sine theta cosine theta d theta. You can do this, after this step, you can do by several methods. You can substitute sine theta equal to u, and then cosine theta d theta would be du. You can use substitution method. We can also use sine 2 theta, double angle formula, which is 2 sine theta times cosine theta from our trig class. So if you divide by 2, you get sine theta cosine theta equal to half of sine of 2 theta. That is 1/2 sine 2 theta d theta. You can take the 1/2 out. Integral of sine 2 theta d theta. You know that integral of sine 2 theta is negative cosine of 2 theta over 2 plus c. That is negative 1/4 cosine of 2 theta plus c. So I would like to mention here that you will be using this particular formula many times, meaning that integral, whenever you have integral sine of k theta, if you have to integrate that, sine of some number times theta. In this problem, it is k equal to 2. So I'm giving you a generic formula. How will you integrate sine of k theta d theta? So it is done by substitution method. So substitute u equal to k theta for du equal to k d theta. So this integral sine of k theta d theta would become sine of u, k theta equal to u, and then d theta is actually du over k, 1 over k du. So it is 1 over k integral sine u du. So it is 1 over k negative cosine u plus c. That is negative cosine of, if you replace u with k theta, then it is negative cosine of k theta over k plus c. So if whenever you integrate sine of k theta, sine of some number times theta, then it is negative cosine of that number times theta divided by that number. Whatever the coefficient of theta is, that comes in the denominator. Here in our problem, the number in front of theta is 2. That's why you have the number in the denominator as 2 as well. Same thing, if you want to remember, integral of cosine of k theta d theta is sine of k theta over k. Okay? Remember these two formulas. We will be using them often. Try the next example. Integral sine x plus cosine x the whole square dx. So I is integral sine x plus cosine x the whole square dx. Note in these problems, we are only expanding. We are, in fact, simplifying the integrand. So simplifying the integrand is one technique. So if you expand this, it's going to be sine square x plus cosine square x plus 2 sine x cosine x. That is integral sine square plus cosine square equal to 1 by Pythagorean identity from trig 1 plus, and then this 2 sine x dx, 2 sine x cosine x equal to the double angle sine 2x, so sine of 2x. So when you integrate that, integral of 1 is x, then integral of sine of 2x, just now we saw in the earlier problem, that is negative of cosine of 2x times divided by the number in front of x, the coefficient, that is 2 plus c, or I equal to x minus cosine 2x over 2 plus c. Let's try the next example. So the three examples that are shown in this part involve simply expanding the integrand, or simplifying the integrand. That's all the technique that we learned here. The second technique could be just look for an obvious substitution. Substitution is the very first technique that you learned in calculus 1 class. So that is something that you should not forget. Sometimes it may be as simple as a simple substitution for the problem, which might work. So integral x divided by x squared minus 1 dx. So we notice here the denominator is of degree 2, the numerator is of degree 1 degree less. Anytime you have the variable in the denominator 1 degree more than the numerator degree, the substitution would be just the denominator equal to u. So u sub here, u equal to x squared minus 1, or du equal to 2x dx. So I, which is equal to integral x divided by x squared minus 1 dx, is u in the denominator. The numerator is actually x times dx. X times dx is half of du. Half of du. That half can be taken out of the integral sign being a constant. Integral 1 over u du. That is 1 half ln of absolute u plus c. Make sure your answer does not have u, which you introduced. You have to get back to the original variable, which is absolute x squared minus 1 plus a constant. So we have learned one of the several techniques. Look for my next video for the other strategies.